We good? All right, welcome everyone. We'll go over a review for midterm number 2 of Eco 1001. All right, so for the first 10 questions, we'll be referring to this figure. In this figure, we have, as usual, price on the y-axis, quantity on the x-axis, and we have domestic supply and the domestic demand curve. The first question is, assume the world price for this market is $12. With trade, what would happen? Well, first of all, if we don't allow for trade, what would be the equilibrium price in this market? Just the domestic price. It will be whenever they intersect, right? So the supply and demand domestically intersect at this point. So the equilibrium domestic price is $10.50, right? And the equilibrium quantity would be, well, we'll find it on the x-axis. So that's what, 18, right? 18,000. All right, so that's without trade. Now we're allowing for trade, and we're told that the world price is $12. So the world price is actually higher than the domestic equilibrium price. So would this country import or export the good? Export, right? Because at the world price, when it's higher than the domestic price, we're at 12 here, that's the world price. If we go across, then we see that the quantity supplied is going to be higher than the quantity demanded, right? And that makes sense because when the price is higher, producers are willing to sell more and consumers are willing to buy less. Right? So we have quantity supplied higher than quantity demanded. And obviously, the difference between those two would be the amount of units that this country is going to export, right? So we just need to figure that out. So at the world price, okay, at the world price of 12, quantity supplied would be 20,000, and quantity demanded would be 10. Right? 10,000. So this country, because it supplies more than the domestic demand is, they're going to export the difference between the two. So export 10,000 units of this good, which is the answer. Right? So this is answer number A. What if the world price was lower? Then we would import. Right? Because then the demand is going to be higher than the supply, and the difference is going to be the amount of units that we need to import. All right. So this is A. Okay. If the world price of this good is 9 per unit, what are the gains from trade? All right. So now the world price is actually below the domestic equilibrium price. Where are we? Okay, so here we have a price of 9. That's the world price. And as we said before, we're going to have imports because quantity demanded is higher than quantity supplied at that price. And the number of units that we're going to import would be, let's see what that is, 25 versus 16. So 9,000 units we're going to import, right? This is import. Now the question is, what are the gains from trade? Are we going to have gains from trade? Is that always going to be the case? Yes, right? Whether the world price is above or below the domestic price, by allowing trade, we will always have gains. Now, it's going to depend whether the price is below or above. It's going to tell us whether consumers are going to gain from trade or producers are going to gain from trade. Right? So in this case, we have, first of all, without any trade, we know total surplus is consumer surplus plus producer surplus, so it's the area of this big triangle here. Right? So this is without any trade. Total surplus would be this area. Now, when we allow for trade, what happens? Now, the new price is $9. And by definition, the producer surplus is below the price above the supply curve. Right? So now we have producer surplus is going to be below the price but above the supply curve. So it's going to be this area. Right? That's producer surplus. But what is consumer surplus going to be? Well, again, by definition, above the price, below the demand curve. So now it's going to be this whole triangle here. Color, do I use this one? So now this is consumer surplus. And you can see, so the blue, well, the big triangle here, that was total surplus before trade. And now with trade, we have, well, basically an extra area here of this little triangle. Right? So what happened when the price is lower? Producer surplus is reduced, right? Producers get less. However, buyers, consumers get more. And it would always be the case that the benefit to the buyer is going to outweigh the surplus loss to the producer. Okay, that's always going to be the case. And if the price were higher than the domestic one, then we'll have it the other way around. So then producers are going to gain, buyers are going to lose in terms of surplus, but still the total is going to be higher than before, than when we don't have trade. Right? Does that make sense? So the gains from trade are whatever the area of this triangle here is. If you want to have it as a formula, so let's figure out what that, how to find the area. So the base of this triangle is the difference between the quantity demanded and quantity supplied at the world price, right? And if it were below the domestic price, then it would be quantity supplied minus quantity demanded. So I'm going to put this in a way so you can use it for both exports and imports. Right? So the gains from trade are going to be, I'm going to put this as the absolute value. Right? So in our case, is the difference between quantity demanded, how do I put it, at the world price, and quantity supplied at the world price. Right? And then what's the height of this triangle? Oh yeah, but what does it represent? It's the difference between the prices, right? The difference between the domestic price in equilibrium and the world price. And again, if the world price is higher, then it would again be the difference, right? So I'm just going to put it again as absolute value. So it's this times the difference in the prices. So the domestic price minus the world price in absolute value. Well, the whole thing divided by 2. Because it's formula for triangle. Right? Does that make sense? So you can apply this whether you have exports or imports, that's going to be. So this is basically the amount of units that we export or import, and this is the difference between the two prices. The whole thing divided by 2. Right. So what is the question?
Multiplying those together?
Yeah, I just didn't have time to put it there. Didn't have space, sorry. Okay, so what's the quantity demanded at the world price in our case? So the world price is 9. So the demand curve tells us it's, they do it, right? 25. Do you see it? It's here. So we have 25 minus, and then what's the quantity supplied domestically? 16 minus 16. And then this times the difference in the prices. So we have 10.5, that was the domestic equilibrium price, and the world price is 9. So it's 10.5 minus 9. The whole thing divided by 2. So what is it? 9 times 1.5 divided by 2. This is 6 point something. 6.75. Well, that should be in thousand actually. Right? $6.75 thousand, because quantity is in thousand. Any questions? The answer here is D. All right. Third one. Assume that the world price is $7 and that there is a tariff of 1.5 what would this country do? All right, so let's get rid of this. Okay, so the world price is $7. So we're here. And without any tariffs, what would this country do? Import or export? Import, right? Because demand's higher than supply, so they're going to import. Now, however, we have a tariff. So basically increasing the world price. That's kind of what we're doing. And with the tariff, which is 1.5, the price of this good is actually 8.5, right? So we are going to end up being here. Okay, so with the tariff, would this country still import? Yeah, right? Just less. Okay. Again, figure out what the quantity demanded is at that price with the tariff and the quantity supplied. The difference between the two is going to be the imports, quantity of imports. So at the price of 7 plus 1.5, which is 8.5, quantity demanded is here, right? When they intersect the demand curve. What is that? 28, right? Yeah. So it's 28,000, and the quantity supplied at that price is 15. Yeah, 15. Therefore, they import how many units? 13,000. Okay. So here we have A, answer A. Right. So in the next one, we still have the same situation. We have the world price being 7, a tariff of 1.5. The question now is the amount of revenue collected by the government. Right. So the government is going to, because it imposes a tariff, is going to collect the amount of the tariff times the number of units imported, right? So this is just that. You have a question? No? Okay, so government, how do I put it? Government revenue is going to be the tariff times the quantity imported. Well, the tariff is 1.5, right? We know what it is. And we saw that they're going to import 13,000 units. So what is that? 1950, right? 9,500. That's how much the government will get. And what it is in the figure, it's actually the area of this rectangle. Wait, not this rectangle, this rectangle. Right, this is the government revenue. It's the tariff, right? It's a rectangle. So this one side is the tariff, the other side is how many units we import after the tariff. So this is the surplus, the amount of the total surplus that's gonna go to the government. All right? What did we say? 19,500. Any questions so far? Yeah?
With the triangle above the tariff, would that be then total surplus at that level?
The next question is going to answer that. Yeah, let's go there. Okay, so the next question is, again, assume that the price is 7, we have the tariff of 1.5. What is deadweight loss caused by the tariff? So the deadweight loss is always how much we lose in terms of total surplus. And the question is, what is the deadweight loss due to the tariff? So we are going to compare the total surplus before we impose the tariff with the total surplus after. All right, so First of all, consumer surplus. No. Okay, so let's start with before the tariff. If we don't impose the tariff, then the world price is going to be $7. Consumer surplus is going to be, again, below the price, above the supply curve, so this area. Sorry, producer surplus, you're right. And then consumer surplus would be above the price, below the demand curve, so it's going to be this huge triangle here. Right? That would be if we do not impose a tariff. Now we do impose a tariff. So what happens with producer surplus? Well, producer surplus, now the price is 8.5, right? So it's below the price, above the supply curve. So it's this triangle. Put it somehow. Okay, so now that triangle here is producer surplus. Consumer surplus above the price, below the demand curve. So consumer surplus would be this triangle. However, the total surplus, the part that goes to the government is also part of total surplus, right? So this rectangle here is also going to be part of total surplus. I don't know if you can see this, but compared to before, what did we lose? The two little triangles on the side of the government, right? And that's always going to be the case again. So what we lost, color red, is the area of this triangle and plus the area of that triangle. That's the deadweight loss due to the tariff. All right? Let's again have this in a formula so we can apply it to any problem. Okay, so let's figure it out. These two are right triangles. Okay, so one side is going to be, what is that? What does it represent? It's the tariff, right? So one side is going to be the tariff, and the same for that one. So deadweight loss due to the tariff is going to be, well, okay. So the tariff times, what is this side here? What does it represent? It's basically this distance, which is the quantity supplied, right, that we gained due to the tariff. And then this, the same side for the other triangle would be the quantity demanded that we lost because of the tariff. Right? So again, I'm going to put it as absolute value. It should always be positive, right? Whether the price is above the domestic one or below, it will always be positive. So just put it as a absolute value. So tariff times, this is the quantity supplied with the tariff. So quantity supplied with minus quantity supplied without. Right? This thing divided by 2 is the area of the first triangle. And the area of the second triangle, so plus, again, we have the tariff times, but now we have the quantity demanded without the tariff minus the quantity demanded with. And then again, divided by 2. That formula will give us the deadweight loss due to the tariff. Okay. Now it's about plugging it in. Let's see what we have. So the tariff is 1.5 times, what's the difference in quantities? Well, it's 2. Right, from 13 to 15 times 2 plus 1.5 is the tariff times, what did we lose here? 2, 4, 5, 6, 7, 8. So that's 35. No, what is it? Wait. This is 28. And this is 36. No, 35. All right, so 7. Right? The whole thing divided by 2. what is that? 1.5 times 9 divided by 2 times 4.5, it's 6 point something. 6,750. All right. This is the deadweight loss due to the tariff. Any questions? Okay. So we have C here. All right. So now we have a different scenario. Let's clear this. Again, so now we have the world price being 9, still below the domestic, so we're going to import. However, there is an import quota of 5,000 units. How many units are produced domestically? Okay, so first of all, at a price of 9, where is it here? How many units would we wish to import optimally? Where is it? Well, the quantity demanded is 25. And the quantity supplied domestically would be 16. Right? So how many do we want to import? 9,000. However, we have a quota of 5,000, so we cannot import what we want or what is optimal. Okay, so up to this point, so up to the 16,000 units, we're going to use domestic suppliers. Then from the 16,000, for the next 5,000 basically are going to come from abroad, right, from the imports. So we have 1, 2, 3, 4, 5, up until here, right, those are the imported. Okay, so ideally we would get the other 4 from abroad as well, and the price will be 9. That's not allowed though, all right, because we have a quota. So what happens after the 21,000 unit? But there's still demand for this good, all right? So then again, the domestic suppliers are going to pick it up. And the way it looks on the graph is the whole supply curve after that point shifts to the right. So basically the supply curve is going to have exactly the same slope, but it's going to be shifted 5 units to the right. So up to this point, let's find another point. So 1, 2, 3, 4, 5. Okay. So the domestic suppliers again pick it up. In this market then, what is going to be the equilibrium quantity sold? It's going to be again where demand and supply intersect, and that is at this point now. Okay. How many units are going to be sold in equilibrium in this market with the quota? Well, a total of 21, 22. All right, does that make sense? So the quantity in equilibrium in this market with the quota is 22,000 units. The question is, how much of those 22,000 units are supplied domestically? Well, we know we imported 5, right? So whatever's left is what the domestic suppliers produced. All right? So imports are 5,000, therefore domestic suppliers 17,000. Okay, does that make sense? Yeah. Question?
Yeah. So the new supply curve is right after that point, not the whole supply curve is shifting, right?
No. So the question is whether the whole supply curve is shifting. No, the supply curve for the first 16,000 units is the one that you see. It's yeah. It just then jumps with 5,000 units to the right, or with the amount of the quota, right? So whatever is allowed. What will happen if the quota was 10,000? Well, it will be done, right? Because we only want to import 9,000, so the quota really wouldn't have any effect, right? But because in this case the quota forbids us from importing the quantity that would be optimal, then domestic supply is going to pick it up. So basically, if you want to see it here, so domestic supply is coming the first 16 units domestically. Then the next 5,000 from 16 to 21, those are imports. And then the last unit here, this is imports. And then the last unit here is again domestic. So 16 plus another one at the end makes 17,000 units supplied domestically in total. Okay. Questions? Okay. All right. Suppose there is a $2.5 per unit negative externality associated with the production of this good. Right, so we're no longer looking at trade. That's another question. It's about externalities. What would total surplus be without any government intervention? Okay, so the government doesn't account for the fact that there's a negative externality, allows the suppliers and, and buyers to interact freely. And we know when that happens, we get at the equilibrium price here, right? Equilibrium price of 10.5 and equilibrium quantity of 18,000. So first of all, if there is no externality, what would total surplus be in this market? The area of the big triangle, right? So let's find that first. So without, if there's no externality, total surplus would be this area. Okay, so theoretically, total surplus would be, what's the base of that triangle? It is, but what is this point here? Sorry? Now what number it is? What does it represent? How would you express this number here?
Demand.
Intercept, right? It's the intercept of the demand curve. And then this would be the intercept of the supply curve, right? So the base of that triangle would be the difference between the two intercepts, okay? So the intercept of the demand curve minus the intercept of the supply curve. And what is the height of this triangle? What does it represent? From here to there. It's the equilibrium, well, the quantity in equilibrium, right? It's 18. So this times the quantity in equilibrium divided by 2. This will be our total surplus. Okay? So now you can just plug it in and see what happens. The intercept of the demand curve is 13 minus 1 is the intercept of the supply times quantity in equilibrium is 18. Okay. The whole thing divided by 2. It's 6 times 18, 108. Right? Okay, so 108,000. Well, this is one of the answers. Is that the correct one? No, because this would be the answer if there were no externality in this market. What does the externality mean? Well, it basically says, when it's negative externality, it basically says that suppliers, well, the supply curve is not the true supply curve, right? There's another cost to this good, whether it's through pollution or whatever else. It is imposing another cost on society. So there's the supply curve that producers acknowledge, and then there is the socially optimal supply curve, right? And the socially optimal supply curve would account for that extra cost, so it would be shifted to the left, so the supply would be lower. It will be shifted to the left with whatever the amount of the externality is, 2.5 units. So the slope is going to remain the same, right? We'll have a shift of the supply curve, and the difference between the vertical difference between the two supply curves is going to be the amount of the externality, right? That's what it represents. So let's shift it here, see what happens. We don't need it for this question, but just to... OK, so the amount of the externality is 2.5. So the new supply curve would have a intercept, right? That is 2.5 units higher. So instead of 1, it's going to start at 3.5 here, and then it's going to be parallel to the original supply. So let's find another point. What is it? Just gonna do it here. There, and then we connect them. Hopefully, not very straight. Anyway, this is the socially optimal supply curve. Right? That's actually for next question. But okay, so in this question, the problem was, okay, what is total surplus without government intervention? So the government doesn't force the market to move to the optimal supply. This will be the total surplus if there were no externality. Now, with the externality, we know that for each unit that is sold in this market, there's an additional $2.5 cost. So what do I need to do? How do I need to adjust this to arrive at the total surplus with the externality? No, so the 2.5 is per unit. Okay, so this is the amount of money that I'm going to be losing per unit that this does not account for. So total surplus with externality is going to be total surplus, well, without the externality. And then from that, I'm going to subtract however many units I sold times the amount of the externality, right? The cost per unit. That will be 2.5. And how many units do I sell? 18,000. Right? 18,000. So total surplus then becomes 108,000 minus 45,000, which is 63,000. Right? And that will be answer D. So when the government doesn't intervene and allows the market to produce in this way, we actually overproduce the good, right? In equilibrium here, we produced 18,000 units. But the true equilibrium, the socially optimal equilibrium quantity would be lower than that, whenever the intersection is here, right? So because there's this cost that is not accounted for, we overproduce the good when the government doesn't intervene, and that's why we get a lower total surplus. If the government intervenes, our total surplus will always be higher. And that's the next question that we're going to do that. Okay, so here was 63,000. Keep that in mind. Okay, so then the next question is, what is total surplus if the government does implement the socially optimal tax? Right? So the government is implementing the tax of 2.5. That's the socially optimal one, which is basically shifting the supply curve and aligning it with the socially optimal supply curve. So when that is done, we are at the socially optimal equilibrium. And what is going to be total surplus here? Again, the area of the triangle. Right? Okay, so let's start here. That's still the formula, but now we're going to have, first of all, the intercept of the supply curve is now higher, right? It's now changed. And the quantity in equilibrium is also going to be different. So let's figure what that is. Let's figure out what that is. Okay, so the demand intercept is the same. It's 13. The supply intercept is now 2.5 units higher, so it's at 3.5. And now we need to see where the quantity, where the two intersect so that we get the quantity equilibrium. Let me see. Well, basically the difference between those two curves should be 2.5. Yeah, I guess I didn't draw it very straight, but if you had, this is where they would intersect. Right? So when you impose a tax of 2.5, that basically means that the difference between the demand and supply is 2.5. And that happens at this point, which is corresponding to a quantity of 15. Right? So this is the socially optimal quantity now, because it reflects the true supply curve. And that's the one I'm going to plug in here. And did I say 15? Okay, so this is 9.5. Oh, sorry, the whole thing divided by 2. So 9.5 times, well, 15 divided by 2 is 7.5. 71. Yeah, it's less than 71,250. And what happened now? When we implement the socially optimal tax, when the government intervenes, our surplus is higher. Right? Even though we produce less, we produce optimally. And optimal, in a socially optimal kind of sense, means that we maximize total surplus. When the government does not intervene, total surplus is not maximized. All right? Questions? Yeah?
Couldn't you use like the theoretical deadweight loss to kind of find your 45,000?
Couldn't we have used the theoretical deadweight loss to find the 45,000?
Yeah, like the tax, because that area wouldn't that be 45,000
The area of this?
of the deadweight loss, like the tax? Yeah, see, it's 3,000 times 3, it's 9, and then you multiply by 10. Does that make sense?
No, this is 2.5 times 3. This is 2.5 times 3 divided by 2.
Okay.
Right?
Oh, okay.
So it's 2.5 times 1.5, which
I'm trying to
does
take
not
the
equal.
triangle.
No, but it's not only the triangle that we take away. This is also taken away afterwards. Right? So basically, yeah, the difference. No, the deadweight loss is different. That's not going to fix, that's not going to give you the correct answer. Why is that though? Because we overproduce. I can't figure it out right now, but this is the right way to go. I don't know if what you're saying is equivalent, but you can, yeah, this is how it works. All right. All right, so another question. Okay, so if this is the market for movie rentals, and firms raise the price from 10.5, which is currently the equilibrium one, to 12.5, then what's going to happen to total revenue of the suppliers, and why? Well, first of all, we need to, this is a question about the relationship between total revenue and elasticity of demand. We need to get this straight, and if we do, we can eliminate basically two of the answers. Okay, so total revenue is going to be price times quantity. So when you change one of those two, when you change the price, okay, whether total revenue is going to go up or down depends on the relative, so it depends on how responsive buyers are to that change in price. In this case, what we have is an increase in price. All right, so price goes up. What's going to happen to quantity when price goes up? Go down, right? Always. That's always going to be the case. So this one, the price goes up, quantity goes down. how total revenue changes is going to depend on the amount of those two changes, right? Okay, it's going to depend basically on whether demand is elastic or inelastic. What does that mean? Elasticity of demand greater than 1, okay, 1 is the cutoff point that tells us whether it's elastic or inelastic. So if it's greater than 1, do we have elastic or inelastic? Yeah. Elastic. Well, the elasticity is basically the percentage change in quantity over the percentage change in price, right? So if it's greater than 1, that means that the numerator is higher than the denominator. So for any change in the price, in this case, think of it in this way. For any increase in the price, quantity is going to decrease, but by more. Does that make sense? No? Elasticity greater than 1. If it's more than 1, that means that the top part is higher than the lower part. So whatever the lower part is, the denominator, the top is going to be higher. So if this changes by 1, this is going to change by 2, right? That's the idea here. And if you increase the price, doesn't matter by how much, right? You increase it with a certain amount. If demand is elastic, quantity is going to fall by more. And what's that going to do to your total revenue? It's going to go down. So if demand is elastic, total revenue goes down as the price goes up. Okay? The inverse is also true. So if demand is elastic and you lower the price, then total revenue is going to go up. Right? So when you have elastic demand, producers should basically have a sale. And that's going to increase total revenue. And okay, so when the demand is less than 1, which means inelastic, well, the percentage change in quantity divided by a percentage change in price is less than 1. So for whatever change in price, quantity is not going to change by that much. So total revenue is going to actually increase as you increase the price. Okay, so the price is going, if you increase the price, quantity is going to fall. That's always the case, but not as much. And that is going to bring your total revenue up if demand is inelastic. Okay, so what we have here, with an increase in price, total revenue goes down if it's elastic, and total revenue goes up if it's inelastic. Looking at our answers, okay, total revenue goes down if it's inelastic as the price goes up. That's not true, right? So that's out. This one is the correct one. And from those, total revenue goes up when price goes up. That's when it's inelastic, right? So this one is out. Those two are the only options. Now the question is whether demand is elastic or inelastic between those 2 points. True? Well, in this case, we actually have the numbers. So we can theoretically calculate the total revenue in one case and the other case and see which one's higher. The first one, total revenue, as we said, is price times quantity. Well, in equilibrium, we have 10.5 times 18,000. That's total revenue 1. And with the change in price, well, the price went up to 12.5. Okay? So now we have 12.5, but what is quantity in this case? Well, we can track it and see. So at 10.5, we're here at 18,000. At 12.5, we're here, which is only about 2,000. All right. So we did increase the price by a little, but then we see that quantity fell by a lot. Right? Just by this, we can figure out that demand is very elastic in that area. Right? And if demand is elastic, then total revenue falls. So it's B. If you don't want to go that way, we can also calculate the elasticity of demand. Right? So elasticity of demand midpoint formula, right? Or just basically the change in quantity quantity 2 minus quantity 1 divided by the average quantity. I'm going to denote that as quantity bar, divided by the change in the price over the average price. That's the formula for elasticity of demand. Quantity demanded changes from 18 to 2 approximately. Right? So this is 16 divided by 17. And then the whole thing divided by price changes by 2.5 over, what is that, 11? Well, is that going to be more or less than 1 is basically the question. So it's 16 over 17 times 11 over 2.5. That's obviously more than 1. And that's why we have elastic demand. Okay, so consumers are very responsive to changes in price. When they're very responsive and you increase the price, they stop buying. Right? And when they stop buying, your total revenue goes down. That's that. Questions? All right. Assume this refers to the market for alcohol. If the government imposes a $4.5 tax on suppliers, how much of the tax is paid by consumers? Right. So the government is taxing suppliers. Would consumers pay any? Yeah. Right? It's always going to be. It doesn't matter whether the tax is imposed on suppliers or buyers. They always share the burden. Okay? And they share the burden when we have linear supply and demand in a certain constant proportion. Right? So whatever the tax is going to be, buyers are always going to pay, like, let's say 20% of it or 60% of it, whatever the case might be. So from this, you can immediately see that A and D are not the answer. Right? So definitely they're not going to pay nothing, and they're not going to pay all of it. They're going to share it. How are they going to share it? Again, if you want to use a formula, the tax incidence on buyers, or the tax burden on buyers, is always going to be the ratio of this side, or this distance, to the whole. Right? They're always going to split it in such a way. As a formula, then we're going to have basically the difference between the demand intercept and the equilibrium price divided by the difference between the two intercepts. Right? The suppliers. And if you were to calculate this for producers, well, it will be 1 minus whatever that is, right? Because they need to add up to 1. But for them, it's going to be the difference between the price in equilibrium and the supply intercept, divided again by the difference between the two intercepts. Okay. In this case, we are asked how much is paid by buyers. So this is 13 minus 10.5 divided by 13 minus 1. So it's 2.5 over 12. Well, it's obviously less than half, right? It's about 20%. So it's not 3.5. We only have 1 and 3.5 left, right? And this is less than half, so it's not 3.5, therefore it's 1. Does that make sense? This is the ratio, right? The ratio of the percentage of the tax they're paying. So the actual amount of money that they're going to pay, tax on buyers, is going to be, well, 2.5 divided by 12 times the amount of the tax, which is 4.5 in this case. Okay. And that is going to be about 1. Questions? Okay, good. So that was, we're done with the figure. Okay, which of the following describes common resources? So that's definition. Who can give me an example of a common resource or common good? What will be a common good? Yep. Fish in a fish in the sea or fish in a public pond, let's say, right? So is this the question is whether it's excludable, non-excludable, and rival or non-rival. So is it a rival in consumption? Yeah? It is a rival in consumption, right? Because the fish that I catch, you cannot catch. Is it excludable? It's not excludable. It's public, so you can't charge me. Right? Therefore, it's not excludable and rival, so it's T. That's the common good. Let's look at the other ones. So what's both excludable and rival? What do we call that? It's private, right? It's a sandwich. If I eat it, you cannot eat it, and you can charge me for it. So it's both excludable and rival. That's private. What's non-excludable and non-rival? That's public. Can you give me an example? Air. Fireworks. Right? You cannot charge me. Well, you cannot stop me from enjoying fireworks, right? Because they're right there. And the fact that I'm seeing it does not prevent you from seeing it. Okay? That's public. And what about the last one? What do we call that? Club good. So it's both excludable and non-rival. An example? Cable. Okay? The fact that I have cable does not prevent you from having it, but you can charge me for it. Right? That's club good. Right. So here common is D. Okay. Suppose supply is given by this equation and demand is given by that equation. Price is in dollars, quantity in thousands. What world price would cause exports of 10,000 units under free trade? Okay. So let's have a picture. Have supply, demand. When will we have exports? When the price, world price above or below the domestic? Above. Okay. So we'll be somewhere here above the domestic equilibrium. To have exports, that means that quantity supplied is higher than quantity demanded, and that happens at higher price. Well, we are after the price that makes this difference in quantities 10,000. Right? That's what we need to find out. So basically, this is the quantity supplied at the world price. And this would be the quantity demanded, again, at the world price. And I want this quantity supplied minus the quantity demanded to be equal to 10,000 units. True? The price is the same. Right? So what I need to do is, because I'm given the supply and the demand curve, I need to first express it in terms of quantity equals something, right? And then just look at the difference between those two, set it equal to 10,000. Okay, so quantity demanded, well, quantity supplied from the equation. Price equals 5 plus quantity supplied. So quantity supplied equals 5 minus the price. Right? Then I'm going to do the same with the demand curve. So price equals 6 minus 2 quantity demanded. So quantity demanded equals 3 minus 0.5 price. Do we see that? we're solving for Q in both of those equations. We need to express Q in terms of price instead of price in terms of Q. Okay. Then I'm looking at the difference between those two, and they happen at the same price, right? So the price is going to be the same. So instead of the price supply and price demand, I'm going to just plug in here the world price. Then I'm going to have one equation, one unknown, and that's it. Right, let's see what happens. Quantity supplied is 5 minus the world price, and then minus quantity demanded. So don't forget to distribute the negative. Right? So minus 3 plus 0.5, the world price. Is that true? No. My bad. This is the price minus 5. Okay, that makes more sense. And then plug in here. Okay, so the world price minus 5, and then minus 3 plus 0.5 times the world price, and that thing is going to be equal to 10. Okay, this will give me the exports, and I want the exports to be 10. Question?
Yes, so basically did you set them equal to each other on the bottom?
No, this is my equation.
Oh, okay, I get that.
Right? This is my equation.
Yeah.
These are my QS and QD. I'm just plugging them into this equation, and this equation comes from the fact that I want the exports to be equal to 10,000. And exports are going to be quantity supplied minus quantity demanded. All right, so it's 1.5. The price equals, what is it, 18? So the world price needs to be 18 divided by 1.5, and that's 12, right? Yeah. Okay, so at a world price of $12, I'm going to have exports of 10,000 units. That's B. Sorry, B. Okay. What if I had, well, the question could have been, what world price would cause imports of 10,000? Okay. So again, I would need the difference to be equal to 10,000, but in this case, it's going to be the difference between the quantity demanded and the quantity supplied, right? So these two are going to be switched if the question were about imports. And in that case, I'm going to get a lower price. Okay. Does that make sense? So be careful which one you put first. Okay. Right. Mike Miller is a town manager, a town of 50,000 residents. At a recent town meeting, several citizens proposed building a large public swimming pool in the center of town for all of the residents to enjoy. A survey of all 50,000 residents revealed that the pool would be worth $50 to each of them. So if this pool is worth $50 to each of them, what is the total value of the pool to the community? Right, it's $50 to each person, and there's 50,000 people, so it's 2.5 million. Right? That's what they value it at. Okay, because the cost to build the swimming pool is only $1 million, right? So its total cost is $1 million. The manager arranges to have the pool built. Everyone in town enjoys the pool, but when the manager asks for donations to pay for the pool, he only collects $250,000. Right, so he fell short. They soon realized that what happened. Okay, so was the survey conducted improperly? No. The cost of the pool exceeds the social benefit. Is that true? No, right? We know the cost is 1, the social benefit is 2.5 million, so it does not. The pool is a club good. No, because club goods you can charge for, right? So the pool is not the club good. Therefore, most of the residents of the town are probably free riders at the pool. Okay? That is the problem that we get with public goods, right? We get free riders. Since the pool's already there, I mean, it is worth $50 to me, but it's already there. So whether I give you the $50 as a donation or not, I'm still going to use it, which will make me a free rider. And that's what happened in this case. Okay? All right. The price of potatoes rises due to a drought. What happens in the market for French fries and ketchup sold in fast food restaurants? Okay, so we have potato price going up. Let's look at the two markets. Let's look at the market for French fries first. So this is French fries. What is it? Supply, demand. Okay. So the price of potatoes is going up. What is potatoes in the market for French fries? What do we call it? What is it?
They go together.
No, that's not what I'm after. What is potatoes in the market for French fries? What is potatoes? What are French fries made of?
Oh, potatoes.
So the potato is a resource, right? When the price of a resource goes up, it's a resource in the production of French fries, okay? And if that price goes up, what's going to happen to this market? Supply going down, okay, shifts to the left, right? Because now it's more expensive, that's what it is. It's more expensive now to produce French fries, therefore supply is shifted to the left. Well, when supply is shifted to the left, what happens with the price and quantity compared to the original? Well, price goes up, quantity goes down. Okay? So now we consume less French fries. And the equilibrium price is going up. Now all of the answers say that the equilibrium price is going up, so that doesn't help us much, right? We do know that the quantity consumed of French fries is going to go down. Now the rest of those statements has to do with the market for ketchup. So let's look at what happens in that market now. Now let's get back to you. What are French fries and ketchup? Complements, right? You consume one with the other. Okay, so this is before any changes, supply demand. Okay, so now we consume less French fries, and those two goods are complements. So what is that going to do to the market for ketchup? Demand's going to go down. Okay, so there's no supply effect here. Here we had a supply effect. There's no supply effect here. There's a demand effect here because they're complements, right? Because they go together. If we don't buy that much French fries anymore, we're not going to consume as much, or we're not going to demand as much ketchup. So there's a shift of demand to the left, right? Demand goes down. And when that happens, what happens to quantity and price compared to before? Both of them drop. So now find the answer that says that. Equilibrium price, okay, always going to rise for French fries, causing the price of ketchup to rise as well? No. Causing the quantity demanded for ketchup to rise? No, it goes the other way around. Causing the supply of ketchup to fall? No, we said there's no supply effect there, right? It was a demand. Causing the equilibrium price of ketchup to fall. Right, that's the one. Because of the shift in demand, the price of ketchup in equilibrium is going to fall. Okay? And in these types of questions, even though there are no numbers, it always helps to have a graph. Okay, so just draw the graph, ask yourself, Is it a supply effect or demand effect? Is it movement along each of the curves or a shift of the curves, right? And then when you draw it in a picture, you can see what happens most of the time. All right.